All right, so this page is really going to be all-inclusive and sort of review of all the things function domain related. So it's a little early since we were just starting it today as today's work, but it's a great review, and these videos are posted in the information station after the fact, so not Edpuzzle style, just videos in the information station. If you want to go back and like study before a quiz or reference before the EOC, or any of those fun things, or after a quiz when you're like, I thought she said this, why do I not understand now? These will be there and available. So even though it may feel like a lot in the beginning, it is something you can reference back to, I guess, what I'd like to know. So in the beginning, the very first one and number 2 are more definitions to make sure we're all on the same page. So when is a relation a function? And it's a function when the x values have a single, ooh, I can't spell single, y value. So there's exact, and that's not very mathy. The more mathy term would be there's exactly one output for every input. So there is no repeating x values. The x values cannot repeat in a function. So maybe that's another thing. X values cannot repeat. What are some ways to tell a function a relation is a function? Relation is just a list of coordinates. It can be dots on a plane, on a coordinate plane. It can just be a table, or it could, like I said, be just a list of coordinates. That's a relation. The function part is where you have to decide. And again, you can look through the table and see, do the x values, they don't repeat. And then visually, like on a graph, it would be the vertical line test. And that just means that that vertical line, so up and down, never touches the graph or set of relation points. So if they're not continuous, then they can't touch 2 points at one time. So vertically, it can never touch 2 points one time, more than one time. Domain, what is the domain of the function? I always think x values. So it's going to be my left, right of the graph. How far left and how far right does the graph go? What is the range of the function? That's going to be your y values. So, or output. X values are input, y values are output. Your y value, so it's going to be the up and down. How far up or how far down did the graph go, or the function going to exist? Given a member of the domain, how do you find the value in the range? So if I give you an x value, how do you find the y value for that function? We're just going to plug it in. Plug it into the function. Because for every input, that'll be your domain, you'll get one output. So if you're given a domain and asked for another range, then you're just going to plug it in to solve for that y value. So function notation will be starting the number 3 and number 4. So f of x, g of x, k of x, whatever letter you choose. It could be r of x, e of x, s of x. If you wanted to use your initials, it's just notating which function you're referring to. So like f of x, I always, for some reason, think of Frank. So that means we're talking about Frank function. So don't let the f of x or g of x or the change of those letters really like mess you up, because all it is making sure that if there might be a list of functions, that you know which one they're referring to, especially when they're trying to get an output or a new output for this. And so f of x is also the equivalent of y. It's the exact same thing as saying y equals negative 4x minus 7. So sometimes I tell people, if it freaks you out, just cross it out and put a y there. For finding these, what I do have found students to figure out, if f of x is y, that means this whole thing is y. So if I put f of 3 equals, then that means y equals a number. Okay, so for f of x, now it's become f of 3. So we put a 3 in the place of x in this notation, this function notation. So x was replaced with a 3. So when it says find or solve, and it's written like this, all you did was take that x out and put a 3 in the same place, and you're going to do the same for the function. So it's getting negative 4, and we're going to plug in a positive 3 because that's what it's asking us to solve for. And then you're just going to solve it. So we're putting the input value of 3, or the x value of 3, to get an output, to get our y value. So that's going to be a negative 12 minus 7. Just get negative 19. So f of 3 equals a negative 19. So when x is 3, y will be negative 19. Because a lot of students don't realize that this is a conversational question, would be what is y when x is 3? This is f of 3 is saying what is y when x is 3? So y is negative 19 when x is 3. So the second one, what is y when x is a negative 7? Again, because it's f of x, and we change the x to a negative 7. So what is y when x is a negative 7? So you're going to go right back to your equation, and you're going to plug in that negative 7 in the place of x. So negative 4 times a negative 7 is going to give me a negative 28 minus 7 should give me a negative 35. So when x is negative 7, y will be a negative 35. So again, you could write f of, I'm going to go up here. F of negative 7 is equal to a negative 35. So when x is negative 7, y will equal negative 35. I know I'm repeating myself, but the conversational makes way more sense than just this, like the sentences. Because I know a lot of times when you see math problems, you don't really understand what it's asking you for and why. You're just machines and are used to doing it. This is saying the x value. And the reason that's important as well is that these can live as coordinates. So when x is 3, y is negative 19 is going to be 3, negative 19. And that point is a point for this graph, this function. Just like for f of negative 7, when x is negative 7, y is going to be a negative 35. So this coordinate does indeed live on this function as well. Now, the quadratic ones, you just want to be very, very careful using your calculator. Desmos is a little more user-friendly than if you use your TI-83 or 84. It's a little more forgiving because you actually can see the two go up into the exponent portion and then come back down. So it understands a little better. It speaks more student versus just calculator. But in my best practice, as you see, even with the linear ones, I always try to use parentheses anyway, just to make sure me and calculator are on the same page. So I know I'm going to be plugging in something for x. So f of x, again, this is the same thing as y. So the output is this at this point. Output and input. Your input is x. It is independent because y depends on what you plug in for x and what they tell you to plug in for x, like in this case. So f of negative 4 is like the mathy way to read that is saying, again, when x is negative 4, what is y? So you're going to go to your function, and you're going to plug in negative 4, negative 4. You can plug that in your calculator straight across. In Boogie, if it's calculator active, this one may or may not be, to be honest, because it's not terrible numbers. Negative 4 squared, a negative times a negative, is going to give me a positive. So negative 4 times negative 4 is going to give me 16. Okay, no, now this is definitely going to be a calculator active because most of the time they won't make you do a number like that at this point yet. Negative 2 times a negative 4 is going to be a positive 8 plus 1. So we plus that positive 8 because negative times a negative gives me a positive, plus 1. 3 times 16 is going to be, and it's a negative 3. Negative times a positive is going to give me a negative. It's going to give you a negative 48 plus 8 plus 1. That's a positive 9 total. I owe you $48. If I pay you 9, I'm going to continue to owe you 39. So when x is negative 4, y is a negative 39. And as a coordinate, that'd be negative 4, negative 39. Because f of x, as its whole thing, is y. The number in the parentheses is going to be x. So, because again, f of x, we replaced x with the number inside the parentheses. So you're just going to do the exact same thing for trying to find your output or y value. F of 0, I love anything that has multiplication of 0 in it. Makes everything really nice and neat. That goes away because that's going to be 0. Anything times 0 is 0. 0 squared is 0. Times a negative 3 is again going to give you 0. You're going to end up with a plus 1. So as a coordinate, when x is 0, y is 1. Also, if you can train yourself, as soon as you see x as a 0, you know that you are solving for your constant or for your y-intercept as well. So if you're looking at the function up at the top for that quadratic, this guy is that positive 1. That's where this graph is going to touch the y-axis, because if I zero everything else out, that's what I'm left with. So that 0, 1 is going to be your y-intercept. Again, just throwing out some more vocabulary, because that's where that graph, that parabola in this case, because it's a quadratic, which is a little early. We haven't gotten to quadratics yet for our class, but still, parabola will cross the y-axis at a positive 1. Do we have any questions at the moment for function notation? Because I'm going to keep going for domain if you guys are good. Obviously, you're going to get a lot more practice coming. This is kind of like just a quick hit, but okay, thank you, Ryder. As always, holler if you guys need anything. Perfect, thank you, Eli. Okay, graphically, I do not know why, so you guys have to let me know, or else I'll just keep on rolling, because I'm not exactly sure why this gives everybody such a hard time. But it does. So, me understanding why doesn't matter. It's just the fact that it does. So make sure you ask more questions if you don't understand. So domain and range. Domain is your x values, range is your y values. I always look to see if these are arrows first, because that is going to make my life big time easier, because that means it is going to continue in that whatever said direction continuously. Which means I'm not making hard decisions. Now, domain and range, if we're not completely sure that we remember which is which, D comes before R just as X comes before Y. So if that's part of the confusion, remember D comes before R, X comes before Y. So our domain are always our X values, range are always our Y values. And domain just means I'm looking left to right. So how far does this graph go to the left and right? And I would say relative sort of to the 0, like if you start at your origin, if I look to the right, this graph has an arrow pointing to the right, so it's never going to stop. There's not like an end point, but I'm looking to the right, so that's going to be our positive infinity. And then I want to look to the left, and again, there's another arrow, so this is going to be my negative infinity. So writing it in different notations, you will see lots of different notations. Interval notation is my favorite because it makes the most sense, and it's very easy to grasp. So this would be negative infinity to positive infinity, because of those arrows. So that means it'll go right and left forever and ever and ever. Now, another notation would be all real numbers, and that's just an R with a double spine. And so that's just another one. It could be, yeah, we'll leave that one, those two. I don't feel like you see a ton written. It's usually all real numbers, or negative infinity to positive infinity. Do pay attention to the parentheses, which we'll get into in a minute. Because of these parentheses, you can't stand on infinity. It's not a place you can grab, touch, or stand on, so it's a parentheses. It's just sort of, the parentheses are a parameter. Like, so thinking like chain link fence versus a big brick fence. Chain link fence, you can still see through it, but you know that's like the edge of the yard for that person or that house. Versus a brick fence, maybe you can't really see through it unless you do a lot of work to start like looking through little holes. And it is definitely like, this exists, that fence is their yard. Like, you can sit on it. It is, you are sitting in their yard at that point. So bricks would be our brackets, which I'll show you on one of the, number 8 will have a bracket, and so will number 6. Actually, the rest of them will. But parentheses versus brackets do matter, and on multiple choice questions, sometimes that catches everybody because you're not paying attention. You're just looking at these, and you're not looking here. So make sure to turn on your looker for your parentheses versus brackets as well. So range we're looking up and down. So we're trying to decide how far up does it go, which would be our positive infinity up here. So we're looking just at our y-axis, and then our negative infinity down here. Again, if you want to, you can think about going from the origin. So as I look up, this graph is still going up. And as I look down, this graph is still going down. So it's going to be the same thing. All real numbers for range, negative infinity to positive infinity. And this is writing the same thing, just in 2 different notations. All right, number 6. So this one's going to have a little bit more. So domain, a little more conversation. Range. Okay, domain is x values or y values? Is domain x values or y values? Oh, you don't have to give me real numbers. Just our domain's X values or Y values. You don't have to give me actual numbers. Just is it going to be looking at the X axis or the Y axis for domain? If I'm talking to you about domain, should you be looking left or right or up and down? Ooh, okay, domain is X. And then range is going to be Y. So X values because you're going left and right. Y values because we're going up and down. So D versus R, X, Y. Domain comes before range. Alphabetically, X comes before Y alphabetically as well. So domain is always left, right, X values. Range is always up, down, Y values. Okay? All right, so now we're going to get in it. So domain, also we're going to look and see that we see some arrows up here. Domain. I'm looking from the origin and I look to the right. Is this graph going to keep going to the right or is it going to stop somewhere? This is our positive infinity, negative infinity. So looking at this graph that just continues and continues and continues off the page into infinity, we see that it's going to go to positive infinity to the right. And then when I look to the left, there's another arrow, so it's going to keep going to the left. So our domain, again, is going to be all real numbers, or negative infinity to positive infinity. And again, we're using parentheses because you can't like grab an infinity. It keeps moving. You can't stand there. It's not a tangible thing. Now, range. So when we're looking at these, and in class, I usually, like if I'm with you, I like to use Post-it notes. So looking up and down, those arrows, I can't like say it stops here. My window or my graph stops here, but those arrows mean it's going to go on forever and ever and ever and ever. So if I take it and I start looking down, right, from my graph, down, 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 keep going down. Whoops, it's gone. It's done. That's where it stopped, was right there. That's as far down as it went. So range, again, we're looking at our Y. So how high or how low did it go? How high up and how low did it go in the graph? Like we just said, it went up forever because there's arrows. So we know this is our positive infinity. So we know we're going to have a positive infinity. And that was going to be a parentheses because you can't grab it, can't stand on it. The graph down here would be our negative infinity. But it didn't go past this point here, which is, I'll take this away so you can maybe see the number a little bit better, a -4. Now, that graph actually touches -4 and then goes up because this is our vertex of that parabola, which will be 1, -4. So that coordinate does exist. So that's where you're going to put that bracket. That's that brick fence that you can sit on. Brick fence that you know is part of this conversation. All right, so that's just a regular parabola going up and down. So thinking just straight quadratic functions. Linear and quadratic so far. Number 5 was linear. Positive linear because it's increasing going to the right. It's going up in the air as x increases, y increases. So this is a positive linear. This is a positive quadratic. Again, kind of early, but you've done it before in the past, so we just want to dig all that stuff up out from our back of our dusty brains. And I am going to, just because there was a call out, if I can get it. Yep, there we go. Hopefully that will make that a little easier for you guys to see. So looking at number 7, we're going to think domain, range. All right, trick question. Range, x values or y values? Range, x values or y values? Yes, good job. Y values. So range is y values. Domain is x values. So domain is left, right. Range is up, down. Okay, so let's do, we want to see, we do notice that they have arrows again, so that means it's not going to stop going this way. Let's do our domain. Now, hopefully you notice that this looks like a parabola turned on its side. Absolutely. Too good, too good. So turned on its side. If I'm looking left to right, so I see arrows, that means it's going to go to the right forever. This is our positive infinity. So we know we have a positive infinity with the parentheses because we can't grab it. So if I keep coming this way, whoop, I lost my function. It's gone. So I come back. Figure out where it stopped. I'm looking at my x values because it's how far right, how far left. -1, -2, -3. So -3, that is the vertex of that parabola. It does exist there. So you're going to have a bracket. Your brick fence, bracket, brick fence. So that's a domain, left and right. Looking at range, so we're looking up and down. This arrow is going to continue forever and ever, never, going up. So it's a positive infinity, so we know we definitely have a positive infinity. And then this arrow is going to go down, as it shoots off into infinity, down in China, and dig through a hole like one of the good old bunny rabbit cartoons, Bugs Bunny. So negative infinity, parentheses, because we can't grab these, and you may see this written as the double-backed R, which is all real numbers. So all real numbers. Okay, number 8. So this is different. Is number 8 a function? Will it pass the vertical line test? So vertical line test, you can use a pencil, piece of paper, your finger. Does it touch only once? No, it does not. So this is not a function. It is a circle. It is a relationship between x and y values. So it's a relation, but it is not a function. How about number 7? Is that a function? Does it pass the vertical line test? Number 7. So I'm going this way. Boop, 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 boop. Oh, uh-oh. It touches twice, so this is not a function either. So number 7 is not a function either. Number 5 and number 6, the first two, 1 and 2, 5 and 6 are functions because vertically it never touches twice. Boop, still going. 1, 1. Perfect. Also, hopefully, we've learned that this is a quadratic function, which you're going to learn a parabola. And then our linear function here is 1, 1, 1, 1, 1, 1, 1. It never doubles back, so we're good. So as soon as it double backs, like this, it has that turn in there, it's going to be not a function. So vertical line test, just to jump around a little bit, because obviously we know like EOCs and tests seem to jump around. And I've heard lots of students say that's the hardest part. Like if you're just doing all the same question, it's easy. And then when it starts mixing up, it's when it starts getting confusing. All right, domain. Range. All right, are you ready for it? X values are the domain or are they the range? Are X values is discussing domain or range? Yes, good. X values are domain. And if it bends back, it's not always that it's not a function. If it bends because, I don't want to answer it wrong, so where it sounds like this guy bends. So it is a function. As long as it doesn't bend, like you squish it like a sandwich. Like there's not two pieces of bread, like on top and bottom. Tacos are allowed. Sandwiches are not. Maybe is a good way to maybe kind of think about it. So as long as it's up and down vertically, you're fine. If it flips on the side, it's no good. All right, so domain. We're looking at our x values. So this is our positive infinity. This is our negative infinity. If we grab our Post-it note, so if I'm coming across, boop, 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 I see no function. Oh, there's a function. So I'm going to mark this. So when I move my Post-it note, I can read my x-axis. Then I'm going to keep going. Oh, lost my function, so I'm going to back up. So the function is between left and right, between those two, my pink lines. So we have 0, 1, so that's -2. Then 1, 2, 3, 4, 5, 6. It goes all the way out here to 6. They are on those places. It is part of, yep. And then this is going to be a bracket and a bracket because it does exist there. So super close, bracket, bracket. Another notation you may see is they will give you an X. And if you write the small number on the left and the big number on the right, always, so small to big, like put them in order as if you're counting from least to greatest, then your inequalities will always be in that order as well. Equal to is the same as the bracket. If it was a parentheses, there would be no equal to. So interval notation, and then we have our other notation that you will see as well. All right, so we're going to look at range. Range, range, range. So up and down, up and down. So if we look, we're looking at our y-axis. So this is our positive infinity. This is negative infinity. So if I'm looking at how far up, now again, this is not where the graph touches the y-axis, it's how far up the graph goes. So this graph, like we're putting him in a box. Putting him in a box. So it goes all the way up to positive 2, and then it goes all the way down to negative 6. So positive 2, negative 6. That is part of the graph. So you have bracket, bracket, because it's not infinities. And again, you could write it the same way. Inequality is always written this way if you write the small number first. So negative 6 is smaller than a positive 2. I like interval notation because I think it's a little easier, because I feel like inequalities make you feel like you have to do more math and more thinking. But with practice, they're not too bad. Not too bad. How are we feeling so far? Awesome, 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 awesome. Great. Great. So we have gone our 30 minutes, and I don't want to push too far, I guess, because the function notation, domain, and range, the things I have noticed, though, is that the graphing domain and range is the problem that most people have, is reading it from a graph. If it's from a set of points, like it is just a list of coordinates or a table, your domain is literally the x values that are listed and literally the y values that are listed. If it's a function, like they give you the equation, but they don't give you any other information besides just the equation, I would go to Desmos and I would graph it, and I would turn it into like number 5, 6, 7, 8 on this page is what I would do, because that should not be a calculator inactive question that I could imagine. It would be an active question. So you could easily go put it in Desmos and look at it